Hello, and thank you for joining this webinar. We'd like to take a look today at size calibration frequently asked questions. And these are questions that apply to any of the fragment analysis software, gene marker HID, and chimer marker. And so we're going to look at three examples, and we'll do this in slides and then open the software to have it so you can visualize the situation, and hopefully this is helpful. So the first one will be taking a look at why are there red underscores in the egrams and question marks at some of the peaks in the size calibration chart. The second, is there a way to manually perform size calibration if there's a disagreement? And lastly, how to differentiate between loss of resolution from amplification issues and capillary quality in samples that do not contain an internal control probe or internal control probes. So if any of these three are areas where you have questions, please keep listening and watching. Okay. So the first one, why are there red underscores in the electropherograms? And so here we can see a zoom in of the sample, and it's in the green trace, and you can see red underscores, and the quality here is marked yellow because actually it is saturation repair. We'll see that when we go to the software. So we see this in the main window at the analyzed data, and also in the calibration charts. So when we look at the calibration chart down here, on the left is the sample name and a score, and that score is how closely does the pattern of the electropherogram for that sample meet the expected size. And this was GeneScan 500 with some of the sizes disabled, and the disabled ones are in gray and the enabled ones are in red. And so the software is looking at pattern recognition. And so we can see here that each of the peaks with a green triangle is a peak that was recognized as matching the expected pattern. And likewise, at the we see the red underscore. There's saturation in these locations in the FSA file. Some of these peaks have question marks next to them, and that is just the software's way of giving us a little additional warning to say these are areas where there was severe saturation and potentially uncertainty about the allele that was, or the peak that was picked. And then visualizing this, we say, this is fine. These are definitely the size standard peaks, even though there's saturation and this little question mark here. I'd like to point out that the pattern recognition is very helpful because sometimes there are pull-up peaks. We can see here around 90 and another one here before the 200 peak, quite tall. Sometimes these saturation peaks are even taller than the actual size standard peak. And this is one of the benefits of using pattern recognition as part of the calibration. Let's go next and just take a look at the software to visualize this. So here, looking at an example in GeneMarker HID, we see that all of the samples have green size standard sheets, nice linear range. When we look at sample one, though, here's the electropherogram that we had seen in the PowerPoint. And if you right mouse click on the sample, there is the sample information from the FSA file. So this came from the data collection software. If you scroll down to the bottom, you'll see that there are 21 areas of saturation in the file. And so the software is just reading that information from the FSA file and making a red underscore here. And let's take a look then also at the size calibration. And when we look at size calibration charts, we'll just make this a little larger, come over here. Again, we can see that the peaks are, we go to sample one that we were looking at before. Here are the red underscores, but when we look at the plots and the green triangles, we can verify that these are indeed accurate for the size calibration. Okay, the second situation is a question that comes in occasionally, and the big question is what is happening here? If you ever have yellow size warnings in the main screen, and when you go to the size calibration, you see that some of the samples of nice high linear score, but some of them are in the 50s and even 40s. So calibration, as we said, selects the peaks with the best fit to the expected pattern, which we saw was beneficial in the earlier case. It was not using the pull-up peaks. Occasionally, it is possible that the baseline noise has a better match to the expected peak pattern, and that's what we see here. There's a little question mark here. It's kind of hidden by these green triangles where it was finding a better pattern match in the baseline. And so while the best process is to determine the cause of the baseline variability or the migration compression and rerun the CE. But it is possible to rescue these files using manual calibration edits. And so that's what we'll do next. We'll go to gene marker and take a look at how to resolve or how to edit this manually. So this is the project where the screenshots in the PowerPoint were taken. And I'd like to start here on the left to point out that most of the samples, of course, have green linear size calling, but we see that sample 01-4 was yellow flagged, 3-2, this one is green and linear, and 3-3 is also flagged yellow along with these others. So we're just going to use these two, 1-4 and 3-3, to look at examples of how to rescue these samples. When we take a look at it, the first one we see it's really stretched out. And the second one, there are some issues with it. This here at the end, loss of resolution, there will be no rescue for these, but it will be possible. So we kind of zoom in here in the lower size range. You can see that this 40 peak is actually seen as a 60 in -3. So we will be able to rescue these peaks here at the lower range that are high quality. Okay. So to do a manual calibration, we would go to the size calibration icon. And let me go down here and we'll pick 3-3 first. I'm going to keep this sample here so we can see these two are separate or not migrating in the same way. And we'll go here to 3-3. And so we see indeed there was some question marks here on the pattern, some uncertainty, and these not matching the expected pattern. And again, we can't rescue these because that's just too much of a resolution loss. But if there were sizes down here that we wanted to take a look at, the way to add peaks in manual calibration is to zoom in on the area with your left mouse and let go. And then you can easily add each of these peaks by holding down the Shift key on your keyboard and the left mouse and draw a box around the tip of those and then let go. It will put yellow triangles on top and we say, yes, we want to add these peaks to the calibration. And I'll do the same thing over here for this one that was not seen as part of the pattern and say yes. And now that that is done, we've added those missing peaks down here in the lower size range. I'll right mouse click in the electropherogram area, not on any peak, just in that area of the box, and select Update Calibration. When we do this, we want to point out that here's the 3-3 plot, and you can see there's just a missing point right here, where those peaks were not recognized as part of the pattern. They were off by larger amount. And so I'm going to select Update Calibration, and that will update this plot. It will also update the score here. Currently it's at 56. When we click Update Calibration, we see that those points are added to the calibration curve, and it has increased to a 65. It will never get up higher and into the 80s again because of that loss of resolution out here at the higher molecular weight. This goes all the way up to 1200. Okay. But for the lower size range, we've updated the calibration manually, And now the first peak that's recognized is at a 40. And indeed, when we leave this calibration chart and go back to the main screen, we'll see a shift here in this 3, sample 3, close that out, zoom back in, and now we see that sample 3 is indeed lined up correctly for these lower size standards or lower size peaks. Okay. So that was one where we just had to add some that were out of the expected range. I'll go back now to the one that was more severe looking, was sample 4. Sample 014. Here it is. Okay, I'm going to make the screen larger here so we can see. Here's the, it's finding areas in or blips in the baseline that are a better match to this. And so we need to go through and delete each of these. The software does require that you do this manually. It doesn't want to take things out that you're not planning on taking out. So I'm just going to take a moment and delete each of these. Okay, now that each of those baseline peaks have been removed, I'm going to follow the same process with the Shift key and the left mouse key to add these peaks. Out to the last 2 there. Okay. And this one, let me just go locate the, here's the the 1-4. So you can see the ratio plot is quite out of process or out of alignment. So if we right mouse click, we expect to see this 54 score here improve and the ratio plot improve. So we'll right mouse click and update the calibration. And indeed, the peaks are all now recognized and the pattern adjusted. So we've switched it up to a 95. So those are 2 examples of occasionally the analyst may opt to manually calibrate the size standard. Okay, and now the last item that we had was differentiating when there's a loss of resolution. And I want to point out in the main screen, this is in GeneMarker HID, there is a column called full width at half maximum. And full width at half maximum, if is 1 or less, indicates there's a single base pair resolution. And so we can see here some examples. The one on top has lost that single base pair resolution. The example on the bottom is within single base pair resolution. Okay, so this can be caused by amplicons, amplification, or DNA quality factors, excess salt, or failing capillary. And some of the kits have an internal control probes, and please do see our app note for use of the automated evaluation of internal control probes. But if your chemistry does not have internal control probes, one of the things that you'll want to take a look at would be in the size standard, because in the amplicons, it could be from amplification or DNA quality factors, excess salt, failing capillary, but the size standard does not go through DNA extraction or amplification, and so there could be excess salt or failing capillary. And so these are the same samples, but we're taking a look at the size standard. And so here we can see that the size standard in the upper one that had that loss of resolution has the same loss of resolution in the size standard. So that points to either capillary issue or salts. In comparison, here's the sample that has the full width at half maximum, of course, is good in the size standard, as it was in the amplicons. And so that was the third example. So I'd like to thank you for using SoftGenetics fragment analysis programs, GeneMarker, GeneMarker HID, and ChimerMarker. And please let tech support at SoftGenetics know if this video was helpful or to suggest additional how-to videos.